Hello friends, welcome to this session. In this session, we will take some of the numerical problems on the power transmitted by the shaft in the unit torsion. In the earlier video lecture also, we taken some of the numerical problem on the torsion equation, strength equation, rigidity equation. So let us start. Let us take first problem. A solid circular shaft of 6 meter length and inner and outer diameter of 75 mm and 100 mm respectively is subjected to torque of 10 kilonewton meter if G is equal to 80 GPa. Determine the maximum shear stress produced and total angle of twist if shaft transmit power 115 kilowatt at 300 rpm. So this is the problem. So in this problem, our objective is to determine the maximum shear stress produced in the shaft and how much angle of twist after application of the torsional moment in the shaft. So that angle of twist is nothing but theta and maximum shear stress is nothing but tau that we have to determine. So the solid circular shaft is there, means definitely there is only one diameter, that 100 mm is the outer, there is a hollow circular shaft is there, that's why there are two diameters are given. So that's why capital D outer diameter is 100 mm and inner diameter is 75 mm. Length of the shaft is given 6 meter, means 6000 mm by multiplying 1000. Capital T is the torque applied, which is 10 into 10 raised to, which is given 10 only kilonewton meter, but it is converted into Newton mm. So by multiplying 10 raised to 6, first of all convert kilonewton to Newton and then meter to mm. So we require 10 raised to 6. G shear modulus or modulus of rigidity is given 80 into 10 raised to 3 Newton per mm square. So this is the given values in the problem. As we know that T, capital T is nothing but the torque transmitted by the shaft, and tau is the intensity of the shear stress in the shaft. So that both of these values are important, that torque and tau. Capital T is the torque transmitted and tau is the shear stress. So we know this equation, that is because of the power is given, that's why we can use this equation or relation, power transmitted by the shaft. So capital T is equal to 2 pi n T. What here it is a torque, here it is the average torque most of the time. So this divided by 60. So there is only one unknown is there, torque. So all this value you can put here, 115 that it is kilowatt into 60, 2 pi n is the number of revolution, rpm value is given, revolution per minute, that is also 300 rpm is given in the problem here. So there is only one unknown T, so you can simplify this and solve this and calculate the torque applied, so which is 3661 Newton meter. So this T torque we determine. After that we know the torsional formula. This formula we already knows that. So T upon J is equal to tau divided by R is equal to G theta divided by L. So all these parameter, all these terms we knows that already. So by strength equation or strength criteria, we have this equation T upon J is equal to tau upon R. So use this equation and determine the value of tau. So because the J is nothing but the polar moment of inertia about ZZ axis, pi by 32 into d raised to 4, and capital R, this is the radius of the shaft, d by 2, we'll get that R, and put that all this value, only one unknown tau, that shear stress value is unknown, and all other values, that is a capital D and small d, are the outer and inner diameters. So put all this value and determine the tau, that is the shear stress, which is the maximum shear stress. And after determining the shear stress, use the equation rigidity criteria, rigidity equation T upon J is equal to G theta divided by L. So by using this rigidity criteria equation, we can determine the theta value, because our second unknown is theta, that is angle of twist. So by using this equation, theta is equal to T into L divided by Gj. T is the torque applied, L is the length of shaft, G is the shear modulus or modulus of rigidity, J is the polar moment of inertia. That value is here pi by 32 into 10 raised to 4. Because here it is the two diameters are there, so your formula becomes d raised to 4 minus 75 raised to 4. So putting all this value here, 10, that torque 10 raised to 10 into 10 raised to 6, that is Newton into mm, that value, and 6000 in mm. Putting all this value here, so after solving this we'll get the theta value 0.112 radian. So theta is the angle of twist made in the shaft, that 0.112 radian. That's it. Both of these objectives are satisfied or we determine. That is a tau maximum torque, we maximum shear stress we determine, and angle of twist also we determine. Let us take second problem. A solid circular shaft transmit 115 kilowatt at 300 rpm. If permissible shear stress is 75 Newton per mm square and allowable twist is 1.5 degree in a length of 3 meter, determine diameter of the shaft. Take G is equal to 82 into 10 raised to 6, sorry 10 raised to 9 Newton per m meter square. So first of all, in the problem, they given the power transmitted by the shaft, which is 115 kilowatt. Length of the shaft is given 3000 mm. 3 meter is given, but it is converted into 3000 mm. Capital N is nothing but the number of revolutions. So that value is also given 300 rpm, that is revolution per minute. Theta is given 2.5. Here it is by mistake, I think 2.5. Okay, so that theta by mistake here it is 1.5, but that value it is 2.5. So angle of twist 2.5 degree. So we know that from degree to radian we can convert by multiplying pi by 180 here. So you just carefully do this calculation work, because always we want the value in radian. So 2.5 degree multiplied by pi by 180, it is converted into radian. So we'll get that 0.0262 in radian. Tau is shear stress 75 Newton per mm square. Capital D is unknown, diameter of the shaft, and G shear modulus is given. So that value is in GPa. So you convert into MPa or Newton per mm square. So this value Newton per meter square means GPa value. So 82 into 10 raised to 3 Newton per mm square or MPa. So as we know that T is a torque transmitted by the shaft and tau is equal to intensity of the shear stress in the shaft. So they use this appropriate equation for determining the torque. So we have the equation power transmitted by the shaft, capital P is equal to 2 pi n T average divided by 60. So in this particular formula there is only one unknown T. So put all this value here, and that is a P 115 kilowatt, 300 rpm, that N value, and only one unknown torque. So 3.661 kilonewton into meter. So kilonewton into meter means that value it is converted into Newton mm by multiplying 10 raised to 6. So once the torque is determined, we know the equation again, formula, torsional formula, T upon J is equal to tau upon R is equal to G theta divided by L. So as per the strength criteria or strength equation, we have this tau max divided by R is equal to T upon G. So this is a equation as per strength criteria. And in this equation, the J is the polar moment of inertia pi by 32 into d raised to 4. R is the radius of the shaft, because diameter is there. So divided by 2, that R value we can determine. So put all this value here. So there is only one unknown, that is the diameter. Tau T value, that is 75. Here, sorry, tau value is given. Shear stress value 75 divided by d by 2, and torque applied we determined earlier 3.661 into 10 raised to 6, and J is the polar moment of inertia. So by solving this, only one unknown, so we determine this diameter of the shaft 62.82. So we got the here. So by rigidity formula, we know this formula T upon J is equal to G theta divided by L. So after by using rigidity formula also we can determine the diameter of the shaft. So put all these value, because torque, J polar moment of inertia, G is the shear modulus, theta is the angle of twist, and length of the shaft. So once we putting all this value here, we can easily determine the diameter of the shaft by using the rigidity formula also. So that rigidity formula, the same diameter we getting as we have determined in the strength formula. So you can use this formula and you can determine the diameter of the shaft. Okay, here, thank you very much.